Alright, so moving ahead, our next question is the number of customers that enter a store during one day is an example of, obviously it is an example of discrete random variable because we can keep account, we have integer values. Weight of an object. So weight is measured on a continuous scale. We know that weight can be 14.5, it can be 55.6, it can be any decimal value. It is measured on a continuous scale, so it is a continuous random variable. 20% of students in a class of 100 are planning to go to graduate school. The standard deviation of the binomial distribution is, so we know that the formula of standard deviation of binomial distribution is under root of NPQ. Our P value is 20%, so which is 0.2. Our Q value is 0.8 and our N value is 100. So if we go and substitute the values, we have under root of 0.2 into 0.8 into 100, which is under root of 16, that is 4. Okay. Next up, if you are conducting an experiment where the probability of success is 0.02 and you are interested in probability of 4 successes in 15 trials, the correct probability function to use will be, so if we think about it, P is fixed at 0.02, okay, and we are trying to find 4 successes in 15 trials. So we consider NCX, P to the power X, Q to the power N minus X. So this is how we will plot, this is how we will figure out the probability of that particular value, and hence this is nothing but binomial probability function. Next up, in the textile industry, the manufacturer is interested in the number of blemishes or flaws occurring in each of 100 feet of the material. So if you go back and listen to the Poisson distribution video, we discussed there that it tells us something that is happening over a fixed period of time, area, volume, etc. So this is clear example of binomial distribution. This is an example of Poisson distribution. The Poisson probability distribution is a discrete probability distribution. Okay. Next up we have, if P1 is equal to P5 in Poisson distribution, then find the value of mean. So what does it mean? P1 is equal to P5. It just simply means e to the power minus lambda to the power 1 upon 1 factorial is equal to e to the power lambda to the power 5 upon 5 factorial. So if we go ahead and calculate this, we get lambda to the power 4 is equal to 5 factorial. So when you solve this, you will have your value as 3.31. So this is the correct answer. If a random variable x satisfies Poisson distribution with a mean value of 3, so we know that mean is equal to lambda and here it is 3. We need to find the probability that x is greater than 2. So this we have already discussed before, that probability that x will be greater than equal to 2 is equal to 1 minus probability that x will be less than 2. So if we go ahead and expand this, we have 1 minus probability x is equal to 0 plus probability x is equal to 1. And if we put the value here, e to the power minus 3 to the power 0 upon 0 factorial plus e to the power minus 3 to the power 1 upon 3 factorial. Okay, if we go ahead and solve this, we will get 1 minus, if we take e to the power minus 3 out, we have 1 plus 3, which is equal to 1 minus 4 e to the power minus 3. So the correct option is option 4. Consider a binomial random variable x if x1, x2, xn are independent and identically distributed samples from the distribution of x with sum this. The distribution of y as n tends to infinity can be approximated as. So this is a very important property of binomial distribution, that if xi's are following binomial distribution, then summation of xi will also follow binomial distribution. So this is a property that we need to remember. So the correct answer would be binomial distribution itself. Okay. But this is important that each should have same probability p. All these xi's should have same probability p. Then only their summation will also follow binomial. Consider a Poisson distribution for tossing a biased coin. The mean of the distribution, so lambda, which is equal to mean, is equal to mu, the standard deviation. So we know that variance is also, for Poisson distribution, the variance is also equal to lambda. Hence, the standard deviation will be under root of lambda, which is nothing but under root of mu. So, the correct option is option 1. Okay. Okay. Which among the following is standard deviation of binomial distribution? So we just solved a numerical above. The correct answer is under root of NPQ. Okay. Suppose that a book of 600 pages contains 40 printing mistakes. Assume that these errors are randomly distributed throughout the book and X, the number of errors per page, has Poisson distribution. What is the probability that 10 pages selected at random will be free of errors? So let's break it down and understand what the question is trying to say. So our lambda is equal to nothing but 40 by 600, okay, which is equal to 1 by 15, and so our p is equal to 40 by 600, right, which is equal to 1 by 15. Lambda is nothing but np, which is equal to n, that is 100 into 15, 100 into 1 by 15, which is 10 by 15, which is 2 by 3, and the probability function e to the power minus lambda, lambda to the power x upon x factorial. But here x is nothing but 0 because we want it to be free of errors. So e to the power minus 2 by 3, 2 by 3 to the power 0 upon 0 factorial, which is nothing but e to the power minus 2 by 3. So the correct option is option 3. Okay, so this is it for this video. Thank you for watching.